All right, hello, back at it, guys. Before we move on to chapter 8 today in math, I want to review chapter 7 really quickly. Over spring break, I asked you to try to get that chapter 7 review done. Spring break started a little earlier than I anticipated, but I still wanted you guys to get that practice of the chapter 7 review. So before we move on to chapter 8, please put a little time into chapter 7 review. That's page 447 to 452, I believe. I received a few of them in emails, so please try to shoot me your work and I can go over it with you. Here's kind of a little help through it, though. In order to review, I figured that we'll just do some of them together. So if you have your book, you can follow along, and this will help you work through it. All right, the first one, I'm not going to read the whole story problem. But like I said, just in an effort to help you review, let's just kind of look through these. The first one, ultimately, you're going to have to add 1/4 plus 3/4, which equals 4/4, or 1 whole, right? 4/4 we would recognize as being just 1. Okay, let's go on to number 2. Number 2 asks you to basically add together these three people's basic amount of time that they biked. And one of the things that's really useful with this, which comes up later in the review, is the use of the associative property. And with the associative property, you basically can regroup. Actually, in this one, you don't have to regroup because the two numbers we want to add are right next to each other already. So anyway, 1 2/3 plus 2 1/3 equals 4, right? And then let's see here, 4 plus 2 2/3 equals 6 2/3. All right, number 3, they're asking you to subtract 4 1/8 from 2 2/8. Now these are one of those ones where a normal subtraction of fractions is pretty easy, right? 4 minus 2 would be 2, and then you just subtract the fractions. But you run into this 1/8 minus 2/8. Do that for me real quick. Oh wait, it's kind of hard, right? 1/8 minus 2/8. So what you have to do is you have to basically regroup at the top. There's 2 different techniques for doing this. And one of the techniques that we use is basically turning the mixed number. Remember, 4 1/8, that's a mixed number, right? We got a whole number, 4, and then we've got a fraction, mixed number. Turning them from mixed numbers just to improper fractions. Improper fractions is when you have a numerator that's larger than your denominator. So just turn these into improper fractions, and then the subtraction becomes super duper easy. 33 minus 8, or 33 over 8 minus 16/8, and that is 17/8. Now, this is part of a story problem. Basically, in the story problem, the person says the answer is going to be 2 2/8. So that's what the person in the story problem claims is the correct answer. But if you do this carefully, 33/8 minus 16/8 is 17/8. Okay, how many times is 8 going to 17? How many whole times? 2, right? What's our remainder? 1. So that goes over the 8. 2 1/8. 2 1/8 is our answer. That is the correct answer. The person in the story problem said 2 2/8. So the answer is no. No. All right, number 4. Number 4 just basically asks you to model 6/10 plus 2/10. I think this one has to do with fairground. Like 6/10 of the fairground is rides, and 2/10 is something else. I forget what it is. But ultimately, 6/10, we have right 1/10, 1/10, 1/10, 1/10, 1/10. So let's get 6 of them. 1/10, 2/10, 3/10, 4/10, 5/10. There's 6/10. Okay, and add 2 more 1/10, 1, 2. We're up to 8/10. Okay, and obviously all the way across is a whole. So 6/10, which goes to right here, plus 2/10 equals 8/10. All right, let's see here. Number 5, it is a story problem relating to the same thing, and they ask you 6/10, which is rides, minus 1/10, which is like farm exhibits. 6/10 minus 1/10, 1/10 is 5/10. The question is how many more rides, how much more area is dedicated to rides than farm equipment? And you can see that if 6/10 is rides and 1/10 is farm equipment, there are 5/10 more area of rides. A lot more rides than farm equipment, right? All right, number 6. All right, these are just asking you, let's see here, the different ways that you can represent 9/10, I believe it is. And they give you a few different options. 4/10 plus 1/10 plus 1/10 plus 3/10 equals 9/10. 3/10 plus 2/10 plus 3/10 plus 1/10 equals 9/10. 2/10 plus 2/10 plus 2/10 plus 3/10 equals 9/10. That was number 6. And number 6, yeah, they're just asking you for the different ways that 9/10 can be written as a sum of fractions. So those are the 3 correct answers. Those are, let me see here, B, D, and E. A, E, and C are incorrect for your information. All right, number 7. Number 7, Bella brought 8/10 gallons of water on a hiking trip. She drank 6 gallons. How much water is left? 8/10 of a gallon minus the 6/10 of a gallon that she drank. 8 minus 6 equals 2. 2/10 of a gallon are left. All right. And then let's see here. The next one was to model 6/10 plus 1/10. And since I don't want to color in the little fraction strips so much that you can't see them, they're kind of just squiggled in. But let's see here. 6/10, there's 1/10, 2/10, 3/10, 4/10, 5/10, 6/10. Got it. Plus 1/10. 6/10 plus 1/10 equals 7/10, right? 7/10 of a whole means 3/10. 3/10 left empty, right? But keep it simple. 6/10 plus 1/10 equals 7/10. Number 9. Okay, number 9. Let me see here what they were asking. Oh, number 9, they just give you 4 different problems, and they ask you if it's a commutative problem or the associative problem. Now remember, to associate is to group together. The associative property is just saying that you can change, with an addition problem, the 3 added-ins in addition problem can be regrouped. They can be in different groups and you'll still get the same answer. Notice how these 2 are grouped here, but then in the second time I write it, this guy and this guy became a group. You're still going to get the same answer. And the reason that this is really useful is if you try to do this, you do 4/10 plus 3/10, because right now they're associated or they're a group. That gives us 7/10, right? And then we do 7/10 plus 6/10. Okay, that involves a little bit more brain work, and it's not as easy to do mental math on. But if we go here and we kind of change our association, use the associative property, change our group, 6/10 plus 4/10 equals 1, right? Super easy. 1 plus 3/10 equals 1 and 3/10. See how using the associative property made that so much easier? The other one is the commutative property. The commutative property basically is you can just change the order of an addition problem and it's the same. 2 plus 3 equals 5. 5 plus 3, or let's try that again. 2 plus 3 equals 5, right? 3 plus 2 equals 5. You can change the order and you'll still get the same answer in an addition problem. The order does not matter. In addition, only in addition. All right, let's look here. Number 10, they wanted to know, it was about which one was wrong. And 2 of them are wrong. 10C is wrong and 10E is wrong. I wanted to point out 10C, which this one would be 10C. This is the answer that they gave, and they wanted us to find what was wrong with it. So you look 4/6 plus 5/6, or 4/6 plus 1/6. We know that that is 5/6, right? They wanted us to catch that there was a mistake. That obviously you do not add the denominators. Right? The denominators just stay the same. 6 should continue to be the denominator in the answer. So it should be 5/6. So hopefully you were able to catch that that one was a mistake. Okay? Let's see here. Number 11, you've got to subtract these fractions. Now, this is one of those ones where, okay, 5 minus 2 equals 3, right? Super easy. But then, 2/6 minus 4/6, the bigger number's on the bottom. That makes it a little bit difficult to subtract. So we can just kind of regroup, or we can borrow. Now, the way we did it previously up here was that, up here we just turned the whole mixed number into a fraction, into an improper fraction. But because I want to show you the other technique for number 11. So basically, 5 2/6. I borrowed a whole. I borrowed a 6 over 6. And now I turned it into 4 8/6. Now that's super easy to subtract. 4 8/6 minus 2 4/6 is 2 4/6. All right. Let's see here. Number 12, they were basically doing the same thing, only they didn't do it correctly. It's one of those ones where it was like catch the mistake. When they turned 4 1/3 from a mixed number into an improper fraction, they said it was 12 over 3. And then when they said 3 2/3, when they tried to change that to an improper fraction, they said it was 9 over 3. Both of those are not correct, right? 3 2/3 is not the same as 9 over 3. They didn't do it correctly. 4 1/3 is not the same as 12 over 3, right? Those fractions written, or those written truly as improper fractions would be 13 over 3 and 11 over 3. 11 over 3 minus, or 13 over 3 minus 11 over 3 is 2 over 3, right? They forgot, they did 4 times 3, but then they forgot to add 1, right? 4 times 3 plus 1 would be 13 over 3. 3 times 3 plus 2 would be 11 over 3. I'm out of breath, getting out of shape. Number 13 is just 1/5 plus 2/5 equals 3/5. Number 14, they wanted you to model 3/4. 1, 2, 3. 3/4 is, I think it was for a girl who ran. She ran 3/4 of a mile, and another girl ran 2/4 of a mile. What's the difference? Basically, we took 3/4 and we subtracted 2/4, which left us with 1/4. 3/4 minus 2/4 equals 1/4. Number 15 was something like 2/8 plus 3/8 equals 5/8. Number 16, they ask you to write the mixed number 4 5/8 as an improper fraction. So we just need to multiply 4 times 8, 4 times our denominator, 8, which is 32, plus our numerator, which is 5. And 32 plus 5 is 37. Put that back over our original denominator, 37 over 8. These two equal each other. Mixed number, improper fraction. Mixed number, improper fraction. And that gets us to 16. We're still 5 problems short, but you can see I've run out of space and I can't write on the chalk, or I can't write on the carpet. Mrs. Morgan gets mad when I do the math problems on the carpet. So, or on the rug. So without further math, I bid you adieu. Take care, y'all.